Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. In the last episode, we got to the point where we now have coins popping up out of our power-up blocks, and we can bop our blocks so they go up and down, right? So if I were to just run as Mario, we can bump those blocks and we sort of get some coins popping out of there. In this episode, what we're going to do is, first of all, there's a bug where, say I duplicate this, you don't see it until we refresh, and that's because we have an issue with our batches. And it looks like it duplicated that twice, so that's another thing we'll have to fix. But yeah, so we basically have a problem with our batches where we don't get to see those updates. So let's fix that real quickly. It's pretty easy. If we just go into render batch, the problem that we are facing is basically whenever a sprite is dirty because it's had a texture change, we're not checking for that. So the way we can check for that is we can literally just say, first of all, if the sprite is dirty, that means something about the sprite has changed. And then we can say if we don't have the texture, so in other words, the texture has changed on this sprite and it doesn't actually appear in this batch, we need to move this sprite to a different batch. How do we do that? Well, it's pretty simple. First of all, though, let's just go ahead and we'll say do that otherwise, because we don't care if it has the same texture, then we can just continue. But if we need to move this to a different sprite batch, we can do that pretty simply just by saying this.render.destroy game object, and we'll give it the sprites game object. So we're essentially going to remove it from this batch by telling the render to destroy it. It's not really going to destroy it from the entire world, just the render, which is what we want. And we can say this.render.add sprite.gameObject. All right, so we just let the render take care of this for us. I mean, it's already built to do that, so let's take advantage of it. Now, if we, first of all, delete that. If I duplicate, you'll see we almost get it, but now it's black. And why is it black? Okay, and that took me way longer than it should have. I actually had this as a bug in my final thing too, so I couldn't figure out what was wrong. But what's happening there is basically when we duplicate objects, remember how if we're placing objects, we have to refresh the state machine's textures? Well, we have to do the same thing when we're duplicating those objects too. So if you just go into key controls and then go under where we do the duplication logic, if you just check and see if this object has a state machine, refresh those textures, and that should fix the problem. We also want to check it if we have multiple game objects, so we should copy this, and then we'll just go ahead and place it in here, and we'll do this with the copy. I don't think it's necessary when we're, well, yeah, it's probably necessary in there too. So now if we duplicate, we're fine. If we duplicate multiple objects, I think I duplicated those. Let's see. Duplicate multiple. Yeah, I think I just made a bunch of copies. Delete, delete, delete. Okay, yeah, now we're good. Cool. It's working good though, right? So we fixed that. We just need to make sure that we were duplicating those, and now everything is working good. One other thing I'm curious about real quick too. These are out of sync right now, but if we hit play, yeah, they're still out of sync. We might want to fix that in the future. For now, I really don't care. Anyways, that's good. Now we want to get power-ups working, right? So if we hit that block, we should get a power-up. So let's go into question block, and let's go ahead and implement that logic. Shouldn't be too difficult. I believe, yeah, so we've already gotten the do coin, do power up, do invincibility. So that's all good. Now let's just go to the do power up. I'm not going to do invincibility. I'll leave that for you guys to do as an exercise after the series is done. Basically, we can just check and see if the player controller is small. If it is, we want it to be big. So we'll say spawn a mushroom. Otherwise, I guess we could just say else, because if it's, technically we should check if it's big. So is big, and we can go ahead and implement that real quick, because if it's not small, it could be invincible, or it could be fire, or it could be big. We don't know. So we'll just say is big. Actually, I guess this doesn't matter. Okay. So let's go back into question block. We don't care if it's big or if it's fire or if it's invincible, because basically, no matter what size the player is, we want to spawn a flower if they're not small, right? If they're small, we spawn a mushroom. Otherwise, we just spawn a flower. So we'll go ahead and write that real quickly. And these functions will be very similar to the do coin, except we will just be spawning mushrooms and flowers instead. So we'll say spawn mushroom, and we'll have private void spawn flower. And for spawning a mushroom, what do? Well, we want to generate a mushroom first of all. So we'll say prefabs.generate mushroom, which we don't have, but we will. It's pretty simple. We'll say mushroom.transform.position.set to this guy's position, right? Same thing we did with the coin. And then we're going to go ahead and also say mushroom.transform.position.y plus equals 0.25f. So then we'll just put it on top of the block, which is where we want it to spawn. And then we can just add it to the scene. So we'll say add game object to scene, mushroom. I'm going to copy this because it's literally going to be the same thing for the flower, except this is going to be a flower. And we're going to be generating a flower. All right, and we'll implement all those functions in just a second. I'm going to comment this out for now, just because we're going to be doing that after we make sure the mushroom is working properly. So let's go ahead into prefabs, and we want to create a generate mushroom function. So let's go ahead and copy generate block coin because this is going to be pretty similar. Paste that down there. We'll call this generate mushroom. All right, and we are going to be using the items.png, and we're just going to get a mushroom game object, right? This is going to be game object 10, or I mean sprite 10 inside of this sprite sheet. And the mushroom actually does not have any animation, so we can get rid of that. That makes our lives a little bit easier. It's also not a block coin, so we don't care about that. And then we're going to be returning a mushroom, of course, but we do need to add some physics to this guy because he's going to be doing a little bit more than our other dudes. So we'll say Rigidbody 2D, RB equals a new Rigidbody 2D. Give him Rigidbody. We'll set the body type to a dynamic body. We're going to do sort of the same thing that we did with Mario, where he's affected by gravity, but we kind of control gravity and all that stuff. And we'll say set fixed rotation to true. And technically this stuff doesn't matter since we're going to be controlling all this, but we'll set it anyways. And then we'll say mushroom.add component RB. And then we also want to add a collider, circle collider. So we'll say circle collider equals a new circle collider. And then we'll say circle collider dot set radius to 0.14f, which was what I found to be good. And then we will also add that. So to the mushroom, we'll add the component circle collider. And then we're also going to add a component, which is a new mushroom. And that will basically be the Mushrooom AI. I guess we should call that Mushrooom AI. And then he will have that attached to him. What does that AI look like? Well, let's go ahead and create it. So we'll just create a new class in here, call it Mushrooom AI. We'll say this extends component. Make sure you import that from the right package, which we actually don't need to import it. Let's go ahead and override public, if I can spell right, override public void update float delta time. And we're also going to need to override public void start. And we're going to need a few variables. We'll say private transient boolean going right equals true. So we're going to have them all going right initially, just because that's how it works in the original game, I believe. And then you can change that. So I think we may be changing it in certain scenarios. I'm not sure. I don't know. We'll see. But then we'll have private transient Rigidbody 2D RB. So we'll just get a hold of the Rigidbody. Transient vector 2f speed, which we're going to set to 1, 0. Those were the best values that I found. Private transient float max speed equals 0.8f. So that's like its terminal velocity. So this speed will basically just automatically put him to the max speed almost. So it's like he has no acceleration time, which is what we want. And then we'll have private transient hit player equals false, which this is a Boolean, and it'll just help us keep track of whether or not we've already been consumed, because there is a chance that he's on screen for a couple frames and we just want to make sure that we don't enable collisions. So this is going to help us keep track of that. So anyways, when we start, we're going to say this.rb equals gameObject.getComponent, rigidbody.class, and we're going to play the sound because he should only be appearing whenever he gets spawned in. So we'll say play the sound Powerup appears.ogg.play. And we're going to be making use of the pre-solve function for this guy. So that's cool. We'll get to learn some new stuff. But we'll basically say if we're going right and the math.absolute value of rb.getVelocity.x is less than max speed. So if we're going right and we're not at the terminal velocity yet, we'll say rb.addVelocity speed. Okay, so I guess we actually do let this guy be controlled completely by physics. That's what it looks like I did. So he is controlled by the physics engine, and we just sort of apply some velocity to him, which is cool. We'll say otherwise if we're not going right, and math.absolute of rb.getVelocity.x is less than the terminal velocity. Then we'll say rb.addVelocity new vector 2f negative speed.x and speed.y, which speed.y is just 0, so it's not really going to do anything. But yeah, that should be good. And if we go ahead and test this out real quickly. So we're going to go ahead and make that question block a power up. And if we hit play, we should spawn a mushroom. Or we can crash. I mean, that's always fun too. So if we look at that error, world.createBody right here, we got an assertion error. I bet you we tried to create something while we were locked. Okay, physics 2D create body. If we look in here, yeah. So if we look in here, I'm guessing this is the assertion we hit, which is assert this is not locked. It's not telling us exactly. It's breaking here, but I'm guessing it's hitting this because it said it was an assertion error. Okay, so how do we deal with this? Well, what's happening? Okay, let's think about this for a second. If we look at our question block, we basically are spawning this mushroom. Well, what is spawning this mushroom doing? He's creating a new game object at runtime, and he's adding it to the physics engine, okay? And the physics engine doesn't like that, because if we try and add stuff to the physics engine while we're in the middle of a physics update, it screws things up. So the way we can mitigate this is if we just go into scene, we can just create a queue of game objects that need to be added, right? So up here, we'll have another private list of game objects, and this will be called our pending objects, okay? So these are the objects we want to add this frame, but we're going to wait because we don't want to add it in the middle of a frame because that's icky and causes problems. So we'll say pending objects is a new array list right here. And then when we add a game object to the scene, we basically do all this junk. Well, instead of doing that, let's say if we're running, so we're in the middle of gameplay, we'll just say pending objects to add go. Okay, cool. So that's going to simplify things a little bit more. I'm going to copy that just so I have it in my hotbar or my paste, my clipboard, whatever it's called. Then let's go down to editor update and update because we are going to need to modify both of these. So right here, we loop through all of the game objects. We update them, which is all good. Then we'll loop through all of our pending objects. And we'll say paste that stuff. We'll add it to the game objects. We'll start the game object. We'll add it to the render. We'll add it to the physics. And then we can say pending objects.clear. Cool. So that should take care of this, I believe. So basically, we just wait till the end of the frame. We finish updating everything. And then once everything is done, we add it to the physics in the render. That way we don't end up doing gross stuff. So let's see if that works now. If we run and we hit this guy. Yeah, cool. So now we get a mushroom. He is not moving, but we can sort of knock him around. Oh, and he started moving there. Let's see. I probably forgot to add something, which is why he's doing this. But it's pretty cool. And you can hear it plays the sounds and everything. I don't know how loud it is for you guys, but yeah. We've got our little mushroom buddy. And I think I just found the bug. So basically, if you go into Rigidbody 2D, I was stupid. And where we have add velocity, we're just adding nothing to the velocity. We should be adding the force that we wanted to add to that velocity. So if we go back into there and we hit play, and the reason the mushroom was going once we hit him was just because he had a velocity, so he wasn't stopping. There we go. So he starts going to the right, and then if he were to hit something, what would he do? Well, I'm guessing he wouldn't do much. Let's delete that, and then we'll add a new guy right there. So if we go ahead and press play, if he hits me, he just keeps trying to go right. We don't want that. How do we fix that? Well, we use our pre-solve method. And we're doing this in pre-solve for a very specific reason. So let's go ahead and we'll say pre-solve, which takes in a game object, obj, a contact, a vector 2f, the contact normal. So we get all of this information, who hit us, how did they hit us, right? That's the important stuff. Making him switch directions is pretty easy. We just say if math.absolute value of contact normal dot y is less than 0.1f. So if the contact normal was more horizontal than it was vertical, we'll just say going right equals contact normal dot x, contact normal dot x is less than 0. So if it's less than 0, which means that the contact normal was negative, which means that we got hit on the left side, going right is now true. So we are now going right. Otherwise, we are now going left. So this will be false. What happens if we just do this though? So if we go and we run this, he should switch directions. Sweet. And then what happens when he hits us? Well, he just switches directions again. But also notice one thing. When he hits us, he pushes us. That is not what we want. We want him to stop colliding with us. He basically just does not intercept with us. He doesn't care. There are two ways you can accomplish this. One way is by using collision layers, right? We could have a collision layer, which is players and power-ups. Player does not actually collide with power-ups. So you basically have player, power-ups, do not collide, but player, power-ups collide with the ground and everything else. That's possible in Box 2D, but there is a simpler way, which is kind of hacky, but it's the way I went with because it just makes sense for this. So we could say player controller is the object.get component player controller dot class. So did we hit the player? So did the mushroom hit the player? So if the player controller is not null, we clearly hit the player, and we can do something called contact.setEnabled false. Since we are in pre-solve, setting the contact to false basically means don't solve this contact, which should mean that the mushroom doesn't collide with us. Now let's see if that actually works, because I was having problems with it in production, but we'll see. So theoretically, the mushroom should go through us. He doesn't go through us, but you'll see we don't go back, right? He doesn't apply any force to us, which I guess that is just as good, right? If we just keep going, we can clip through the mushroom now. So that's pretty cool. Yeah. And actually this makes more sense, right? Why are we clipping through the mushroom? Why is he not applying any force? Well, it's because of this line right here. We basically check. So we're still getting the contact normal and everything, but then we set this to false. If we just do this afterwards and then we just return. So if we hit the player, we just sort of exit early, then the mushroom should go right through us, which is what we want. And this is another important concept. There we go. You see, he went right through us, didn't do anything. This is an important concept because this is how you would do like one-way doors and stuff like that, one-way traps, one-way platforms, whatever, where you could jump through one side but not the other side. This is how you would do it in Box 2D. So take this concept, explore it more, do some cool stuff with your games, and show me in the Discord because that would be awesome. Anyways, let's go ahead and power up the player if we actually hit him. So if we didn't hit the player, which means this is the first time we've hit him, this is that we don't accidentally power up multiple times. So he like goes mushroom, then he goes to Fire Mario, then invincible, whatever. We're just going to call this once. So we'll say player controller.powerup, which we don't have yet, but we'll add. And we'll say this.gameObject.destroy. So we destroy the mushroom, and then we'll say we hit the player now. This way, the next time this function is called, if it's called multiple times, we don't end up powering the player up twice. Okay, let's go into the player controller and create a power up method. We'll put it right above the collision. So we'll say public void power up. And it's nice to do this here and just sort of abstract it because we don't want to care about like, is he Big Mario going to Fire Mario? We'll just sort of let the player deal with that, right? So we can go into here and we can say if player state is player state.small. Right there. What do we want to do? We want to be Big Mario. So we'll say player state equals player state.big. We'll say asset pool.get sound assets/sounds/power up.ogg.play. So we play the power up sound. And this is actually going to play. Well, no, it's not going to play regardless. It only plays if we actually power up. So I'll leave it like this. For instance, you could get fire when you're already fire, and that doesn't actually power you up. Then we'll say GameObject.transform.scale.y equals 0.42f. Mario actually gets bigger, so we want to change his scale to reflect that. Then we also need to reset the pillbox collider because the pillbox collider bounds are going to change. So we'll get that component. And we'll say if PB does not equal null. Then we want to say jump boost times equals big jump boost factor. So we let him jump a little bit more forcefully. And then we say walk speed. That was, and we're going to multiply this also. The reason I did this initially was just because I was using Box 2D for actual physics. And when you change the size of a collider, it actually changes the way that forces work because the mass gets spread out in a different way. So physicsy stuff basically makes the forces act differently, and this was to accommodate for that. We shouldn't have to worry about it with the way we're doing it now, but it's good to have it there anyways. Then we'll have set height to 0.63 F. So we reset the height of the pillbox collider to reflect his new height, which should be good. What if he's not small? What if he is? Player state equals player state dot big Mario. Well, if he's big, we want to set him to fire. So say set the state to player state dot fire, and then we want to say asset pool dot get sound. This thing, exactly the same thing. And then last thing we want to do, state machine dot trigger power up. And we don't have to do that differently for small or big Mario since we already set it up to work appropriately. Cool. So this should help us for powering up big or small. If we run this, we should hit that and we power up to big Mario. Cool. And that's still a little bit buggy. I'll have to look into that, see what's going wrong. But yeah, we got big Mario. Sweet. Now let's make it so that we hit this one. Should pop out a mushroom, and if we duplicate that, since this guy is also a power-up, he should hit out a flower. That is, if we're big Mario. He does nothing right now. Why? Well, we didn't implement that. So if we go back into here, we have this spawn flower method. Let's go ahead and actually implement this. We'll go into prefabs. Let's go all the way down. And this one's going to be way easier than the mushroom because we don't have to worry about any sort of physicsy stuff. I mean, we do a little bit, but it's way easier, right? We'll just say generate flower. This is now a flower. His index is 20. Nice. And then we want to give him a rigid body, except he's static. Why? Because the flower doesn't move. It just sort of sits there. We don't care about gravity or anything. We're just going to place it in the correct position, and that's that. And then we're going to add the rigid body to the flower. We are also going to give him a circle collider with 0.14 F. And then we're going to say add the circle collider and add flower, new flower. I'm not going to say flower AI because it doesn't have any AI. It's just a flower. So then if we go back into, or actually we don't need to go into anything. We just need to add a flower component. So if we go into here, say this extends component, and this one is fairly straightforward. We'll just get a reference to the rigid body. So we'll say at override public void start this.rb equals GameObject.getComponent rigidbody.class. Nicely done. We also want to make sure to play the power up sound. So we'll say get sound assets / sound / power up appears .ogg.play. And then we're going to say this.rb.set. Ooh, a new thing is sensor to true. Well, I guess this is just going to set it as a sensor. What is a sensor? We talked about this a little bit. A sensor is just something that doesn't actually collide with anything. So we can do this with the flower since it doesn't collide with enemies or anything like that. And this means we can just run right through it. So if we were to actually run this real quickly, we can get the mushroom. Well, we got 2 mushrooms there. That's also a good test, right? We got 2 mushrooms. Why? Because we were little Mario when we hit both of those blocks. So if we get that and we spawn in a flower, we can run through it and it doesn't stop us, doesn't apply any physics. That is what a sensor is. Those are useful if you just want to trigger or something. Use a sensor. Anyways, we actually want our flower to do something when we hit it though. So we'll say public void begin collision. This takes in the game object, the object colliding, takes into contact, the contact, and it takes in a vector 2f, the contact normal. Let's go ahead and import all this stuff. Import that, import that, import that. And we can say player controller equals GameObject.get, or not GameObject, I'm sorry, obj.getComponent, player controller.class. If the player hit the flower, then we want to power the player up. We'll say contact.set enabled to false. Technically, we don't need to do this. This is a sensor. I'm not sure why I did that, so we could just leave that out. And we'll say player controller dot power up. We will say this dot game object dot destroy. Okay, cool. So this immediately destroys the game object. We might have problems with this. I don't think we should because I think we queue that up, so it should be destroyed at the end of the frame. So if we go and we hit that first one, We power up. We hit this one. And we power up to Fire Mario. It's all working. That is good news. I like it when things work. Unlike the beginning of this video when I mess stuff up. Okay, I'm going to leave it here for now. In the next episode, what we're going to be doing is enemy AI. So we'll probably implement the Goombas and the turtles, get those in the game so that we can use them. And then we're going to get pipes done, and then we're going to get fireballs working. And we need to get the flag so that you slide down the flagpole at the end of the level. And then that should be good. Like, that's pretty much Mario. I hope you guys can begin to see how this is able to build a pretty good game, and you can sort of use our engine now, not have to worry about too much stuff, and it all just sort of works. If you were to build your own game, it would follow something similar like this. One question for those of you who are still with me. So OBS does not capture the mouse cursor very well. Like if I go into here, you'll notice that you can see the mouse cursor over here, but when I move it over text, it doesn't capture it for some reason. So do you think it's better for me to have this highlighted thing and then capture it? Or I could alternatively turn on this magnifier, which captures it everywhere. The only problem is the magnifier messes up my mouse cursor, like when I'm doing certain actions, which is annoying. So let me know if you think the yellow cursor is perfectly fine for all this stuff, or if you would prefer something else, or if you have any suggestions. Any of those would work. Anyways, I hope you guys enjoyed this. If you did, please hit like and subscribe, and I'll see you in the next episode. Thanks.